Bismillahirrahmanirrahim. Assalamu alaikum. I am Sayyid Akif Shah, lecturer finance at Institute of Business Studies, Kohart University of Science and Technology. The title of this course is Business Finance and the course code of this subject is BS 151. This is lecture number 12 and the topic for today's discussion, which is a broader topic we have started, is time value of money. In this topic, we shall be discussing the annuities and numerical cases, and particularly we will be discussing ordinary annuity and its future value calculation. The outline of this lecture comprises of the types of annuity, and specifically in this lecture we will be talking about the future value of ordinary annuity and the numerical cases. So dear student, after listening to this lecture, you should be able to understand, number one, the different types of annuity. Number two, understand how to solve future value numerical cases related to ordinary annuities. So in our previous lecture, we have explained the annuity and the types of annuities. Therefore, we'll quickly switch to the next slide, which were ordinary and annuity due. And then we have explained certain number of examples like student loan payment, car loan payment, insurance premium, mortgage payments, retirement saving as annuities examples. Finally, in our previous lecture, we have explained the steps to solve the future and present value questions under annuities umbrella. So number one, read the problem thoroughly, create a timeline, then put cash flows and arrows on the timeline, determine if it is a present or future value problem. In my previous lecture, I have told you about the hint. How would you determine that if the question is asking you to calculate present or future value? And then fifth, determine if the solution involves a single cash flow, an annual streams, or a mixed cash flow, which will be discussed at the end of this chapter. Sixth, solve the problem, and then finally you can check with the help of financial calculator that either you have solved your question rightly or it is wrong. So let's move ahead and take an example. So dear student, our today's major point agenda or the major focus will be on the calculation of future value of ordinary annuities. So generally, as we have gone through from our previous slide, which was clearly explaining that how to solve your problem. So after reading the problem thoroughly, we are required to calculate a timeline just like this one. So in this case, a particular bank investment is asking us to put $1,000 at the end of each financial year into the bank account, and then at the end of second period, and finally at the end of third year. So therefore, it is an ordinary annuity because the payment by the investor into the bank occurs at the end of the accounting period. So as the amount, which is 1,000 in this case, is same at the end of second year, and then it is once again $1,000 at the end of third year. Therefore, equal cash flows, and each one is one period apart from each other. Therefore, it is known as an ordinary annuity investment. Then we need to explain what is this I. The bank will definitely offer you a particular compound annual interest rate, which is represented over here as I%. In the question, it would be given clearly to you. This R represents the periodic cash flows which occur. In our previous slide, we have explained that 1,000 was the periodic cash flow, and then the question will definitely ask you to calculate the future value of this ordinary annuity. Future value of annuity. If D is not mentioned over here, then it will be future value of ordinary annuity. If after A, D has been mentioned, it will be clear to you that the formula is of future value of ordinary, not ordinary annuity, but annuity due. The formula for calculating future value of this ordinary annuity looks like this in the octagon, which is yellow in color. So the formula starts left hand side, which is equal to future value of annuity subscript n. N represents the number of time periods you are going to invest your money. So in our given case, it is actually 3. So 3 years of investment is asking you to calculate future value of ordinary annuity. R represents the periodic cash flow, which is 1000 in our case, and then it is supposed to be multiplied by 1 plus I raised to the power n minus 1. N is total number of years, which is 3 in our case. You need to put 3 over here, and then minus 1. The reason behind this minus 1 is that this R, which is periodic cash flow, which you will be investing into the bank account, will get double. Not will get double, but rather it will have a compounding impact of this interest, which could be 7%, 8%, 10%, whatever the bank is offering you. So it will compound for 1 and 2 years to reach at the maturity of this annuity. So therefore the total number of period is 3, and minus 1 will give you the resultant value of 2, and this 2 means that the initial investment of 1000 will compound for 2 times. Therefore n minus 1 impact needs to be subtracted over here, and then plus the next years of cash flows. It will compound for how many times? Definitely 1 time. So n minus 2, n minus 2 means 3 minus 2, it will give you only 1. So this cash flow will get compounding impact only 1 time in this given scenario. And finally the third amount, which would be once again another R periodic cash flow, it could be $1000. It will not get any compounding impact, because at the maturity you are going to plus all these your accumulated amounts. So therefore 3 minus 3 will give you 0, and the 0 means anything raised to the power of 0 is equal to 1. So ultimately the final R will remain as it is, whatever you have invested in your bank account as ordinary annuity. So let's remove these highlighting. So this is our basic example of an ordinary annuity, which is asking you, the question might be given to you in a narrative form, like a bank is offering you to deposit, bank is offering you and to invest your money in ordinary annuity, which is of 3 years of time period, and at the end of each period you are required to deposit $1000 at the compound annual interest rate of 7%. So what is the future value of this annuity? So in this octagonal yellow highlighted shape, you can see that we know very well the formula, which is future value of annuity. At the end of n was 3 in this case. R is $1000, which you have put in the formula, and then 1 plus I over here is 7%. 7%, in order to remove the percentage sign from 7, you need to divide it by 100, and this will give you the resultant value, which is 0.07, and the formula in our previous slide was 1 plus I. So therefore 1 plus this amount will give you the resultant value 1.07 raised to the power 2. Why 2? Because n minus 1. N in this case is 3. So 3 minus 1 will give you 2. Similarly, n minus 2 in the next value, the second years of deposit, which is $1,000. Again, 1 plus 0.7 raised to the power n minus 2, and n is 3. 3 minus 2 will give you 1. And finally, this last annuity contribution or investment into the bank, which is $1,000, multiply by 1.07 raised to the power n minus 3. So in n minus 3 means 3 minus 3, the resultant value is 0. And according to the mathematical rules, anything raised to the power 0 is actually 1. So 1 multiplied by 1000, the resultant value is 1000. With the help of any scientific calculator, you can find out the value for first cash flow, which gets compound 2 times, because this first $1,000 of investment will remain into the bank account, and it will get the compounding impact of 7% and will reach to year 2. Certain amount will be over here, and it will once again be left into the bank account, which will get once again 7% compounding impact, and it will reach to the third destination, which is the maturity time period. So you can see with the help of this arrow that 1000 gets jump of 7% to reach at the end of second year, and similarly and once again it will get another jump to compound to this 1145 value. So by using the formula, we come up that, and with the help of simple mathematics, we reach to the conclusion that future value of this ordinary investment opportunity into the bank account will give us $3,215 at the end of third year, because we have 3 accounting periods of investment, and this investment will increase to 3,215. It means that the amount you have actually invested into the bank was $3,000, and this $3,000 over the period of 3 years will reach to $3,215, and this is our future value of ordinary annuity. Dear student, in this slide, we will see an alternative method to calculate the future value of ordinary annuity. This is the second method to calculate future value of ordinary annuity. Now, what is this? This is known as valuation using the table method. And this table 3 means that if you pick up any financial management book written by Getman, Van Horn, or Brigham and Houston, at the end of the book, in an extra section, you can find out the annuities are future, present, and future value table, and then the annuities table. So in that book, in the current book we are using is actually the Fundamentals of Financial Management by Van Horn. So at the end of the book, the table would be numbered as table number 3. Now, what is this system all about, or this mechanism is all about? The question case is same, future value of ordinary annuity. So rather than to use the algebraic expression to calculate the future value of ordinary annuity, we can use the tabular method or table method, and this is a very simple and straightforward method to calculate future value of ordinary annuity. So dear student, future value of ordinary annuity subscript n, once again it represents the total number of year of the annuity, which is 3, total number of time periods in our given case were 3, is equal to R, which is cash flows. It is representing the periodic cash flows, equidistance, same amount of cash flow. We can write I over here as well if you would like to write it down over here. and this I represents the number of cash flows, which are 3 in our case. Back start, future value interest factor for annuity. In this table you will find out this expression, future value interest factor for annuity, subscript I %. This I represents the compound interest rate which will be given into the question, and N represent once again the total number of years for compounding this investment opportunity does exist. So you can simply put in the value. The R, which is periodic cash flow, in our case was $1,000. Future value interest factor 7%, because the I rate given in our prevailing example was 7% and N was 3. So what you are required to do is go to the table number 3 at the end of the book. Now let me explain this table. You can find out that this is a cropped portion of the total table available at the end of the book, and we have cropped the relevant table which will assist us to solve this question. At the top leftmost cell, period will be written, and in the horizontal line, which is a row, first row, percentages would have been given. That could be 5%, 6%, 7%, 8%, 9%, 10%, so on and so forth. So what you are supposed to do is to find out the relevant percentage or the compound interest rate given into the question, which is 7 in our case. So you need to go to the 7% cell, or rather I must say 7% column, and on the vertical side, or in our first column, periods would have been written. That is 1 represents 1 year time period, 2 represent 2 year, 3 year, 4 year, so on and so forth up to 50 years. Table is given at the end of the book. So the question consists of N is equal to 3. The question is actually comprises of the 3 number of time periods our given amount is supposed to be invested into the bank. Equidistant payments are 3. So therefore we will select 3 number of time period from our vertical first column and 7% from the given table, and then you need to find out where they intersect. So the intersection point for 7% compound interest rate at 3 years end is 3.215. So what you are required to do is to pick up this amount from the table and just simply plug into the formula over here. So we have done in a similar fashion. $1,000 was the periodic cash flow, which was $1,000, multiplied by 3.25 factor, which is future value interest factor for annuity at 7% and 3 number of period. You can simply multiply these two values, numerics, and get the required answer, which is 3,215. This is our future value of ordinary annuity. So suppose if the investor is looking to invest in this bank opportunity, which is asking you to deposit $1,000 at the end of each financial year, which will compound at the rate of 7% annually, then resultantly at the end of 3 years, this investor will get $3,215 in his bank account. But what actually the investor has invested was $3,000, and because of the compounding impact of 7%, as this was annuity for 3 years, has come up with $3,215 in his bank account. So ultimately this 215 extra dollar in his account is actually the interest earned or the profit earned over the number of time periods. So you can see that either you're going to use the tabular method, or in the previous case, let me remove these inks, or in the previous slides With the help of formula, the answer was 3215, and with the help of tabular method, the answer is same. It means that you can use either the table method or the formula method as per your ease. But however, in the question there might be written that your student is required to use formula or the tabular method, so you need to be focused and thoroughly read with full care that what the question is asking you to do, you have to follow that method. Finally, there is third method to calculate the future value of ordinary annuity with the help of a financial calculator, which is too much easy. You can simply go to the market, purchase this financial calculator, and simply put in the values into it, and just with the help of single enter or equal, you can find out the answer of future value of annuity. So there might be certain input values which you are required to plug in into the financial calculator, and then you can simply press the enter button or equal button and you will get the future value of ordinary annuity. Now what are these? You are required to input data. In the place of n, press the n, which is n represents 3 periods. Enter as 3 year end deposits. So put value 3 over here. I/y, it represent interest or yield, which is 7% in our given case. So you can put in 7 over here. You are not required to convert it into 0.07 because the financial calculator has been programmed automatically to understand this 7 represents 7% compound interest rate. PV, you are not required to calculate the present value, so therefore it is 0. PMT represents payment to maturity, which is $1,000 negative as you deposit annually. This negative sign has been written over here because you as an investor supposed to deposit $1,000 at the end of each financial year. So therefore you are plugging negative sign over here, which is payment to maturity. And finally FV represents compute the future value. You can press the enter button and the resultant value will give you $3,214.90 future value of this ordinary annuity. Now there is a slight difference between the financial calculator's final value and this tabular method and the formula method calculation. The reason behind this is the precision. The financial calculator is more precise and it uses maximum number of decimal places, so therefore it gives you the exact answer. In the second place, formula gives second priority or second rank precise answer, and finally this table come at rank number 3. However, the slight deviation is not considered. The student will get the marks irrespective of the slight deviation because this is because of the rounding reason. As you can see that in tabular method we have rounded our values up to 3 decimal places. However, in formula manually you are supposed to round certain number of values, so therefore there could be a slight deviation. And similarly this more precise mechanism, which is financial calculator, it automatically uses the maximum number of decimal places, so therefore it gives you the more precise answer of future value of ordinary annuity in comparison to the formula method and the tabular method. So this is all about the calculation of future value of ordinary annuity. Thank you very much for listening to this lecture. If you have any question regarding the future value of ordinary annuity, you can just post them on KCMS and I'll be happy to answer your question. Take care of yourself. Good luck for the day. Allah Hafiz.